Brian Sletten is literally right now writing the book on WebAssembly for O'Reilly Media, and he's here to talk about the same, but most excitingly about how maybe it's not only for browsers. Welcome, Brian.
Thank you very much. Good evening, everyone. It's an honor to be here. Um, a half-hour talk is not a lot of time to show you much mechanically about how WebAssembly works. So what I'm hoping to do instead is to get you excited about it, to get you interested in learning more. There are a ton of great resources out there, and it's, I think, something that's going to really change our industry. The name is a little tricky, WebAssembly. There's a joke that nobody really knows who to assign credit to. That it's not really about the web and it's not really about assembly, but it's a suggestive name, in the idea that we have a new targeted platform that is going to allow us to, in essence, pick whatever language we want to develop in and compile it down to this targeted platform, and then to be able to run it being served up over the web. And part of that benefit is that the binary representation of the code is completely portable, and it will generally run in a sandbox, and it will provide a lot of the things that you may have heard from other platforms, but now in the world of phones and tablets and Internet of Things sensors and cloud computing and edge computing environments and things like that, we need a mechanism for doing that. And JavaScript is still part of that story. One of the other things that people are concerned about is that WebAssembly is about killing JavaScript, and that's not at all the case. So what I want to do is instead give you a vision of what's coming and show you what's already here, and then give you some interesting places to look. So without further ado, I want to mention my background just for two reasons. Number one, about 25 years ago, I was working at a company that worked on building one of the first one of the first whole Earth visualization environments. So think Google Earth, but 25 years ago. And at the time, the web was emerging as well. And there was just no concept that you would be able to do something like that on the web, right? At the time, the web was a very toy product from a user experience perspective. Because we were dealing 25 years ago with terabytes of sensor data and terrain information and hyperspectral imagery and things like that. And it was just, there's no way that something like that would work in the web. I'm here to tell you that that's no longer the case, and I will show you that shortly. And then the other part of that is not too long after that, I was at a company called Parabon, where we were building an internet distributed computing platform where we wanted to be able to run code on idle computers all over the world, to take advantage of those resources, and then to give people the ability to rent out cheap computation. So this was pre-cloud and whatnot. And we're now seeing things like that emerge in the form of edge computing environments. And many of those edge computing environments want you to be able to pick your programming language and run whatever that you want in those, but they want it to run in a multi-tenant sandboxed environment. And so many of those environments are moving towards WebAssembly as the basis for that. So there's, just in my own personal career, two arcs that have really caught my attention as something that WebAssembly will be useful for. But as you'll see, the sky's the limit in terms of where we might go from here. So there's two basic approaches to this. WebAssembly itself makes our code portable. In essence, allows us to pick whatever programming language we want. Ultimately, there are some limitations currently, but that will make us code portable. But then we generally write applications against APIs like Win32 or some of the .NET APIs or the POSIX library APIs. And that's what makes our applications portable. And so the combination of WebAssembly and WASI, which stands for the WebAssembly Services Interface, these are going to make it so that we can write applications that are going to be portable, running inside of browsers, outside of browsers, in Node, in Dino, in various other environments that I'll talk about as well. And that's the really exciting part, because now we're going to be able to reuse code more often. So again, the point is not to displace JavaScript as the main language of the web, but to get code reuse when it's possible. And if there are aspects of our systems that would be better suited in another language, then we can do so and invoke it from JavaScript with very little effort. And so it's a very exciting time, and I encourage you to dig in. Now, I have spoken about REST professionally for quite some time, and this is a image directly from Dr. Fielding's thesis. And one of the things that I always skipped over in my architecture-focused talks is the idea that one of the constraints in the architectural style is the optional code on demand one. In part because for the last 25 years, that has meant one thing. That has meant basically JavaScript. Now, we've seen some additional platforms like Flash, like Silverlight, like Java applets that have emerged in that time period. But those were always running in Sandbox plugin environments. They were not directly part of the browser memory space. And so there was always a disconnect between like the web side of things and the plugin side of things. So the user interfaces didn't work well. Sending data back and forth across these boundaries didn't work very well. But that's changing now. So what we're talking about is being able to operate within the space of browsers and out, but to do so in a safe and sandboxed way. So ultimately, what WebAssembly is providing is a mechanism to deploy code wherever you want, written in whatever language you want. And like I said, that's a promise that we've been given in the past. And one of the reasons that I think that it's kind of taking, or has the potential to take this time, is because we're not trying to force everything, right? Not everything has to be using the same language. Not everything has to be using the same necessary platform, or even the same sort of security configurations. But we're seeing problems even in existing environments like Node, where due to supply chain attacks and whatnot, people are often not careful about the transitive dependencies that they pull in. And this is a new attack vector for hackers to run stuff in our environment, particularly if we're running out of the browser with high privileges. And so the move to Deno is an attempt to solve some of those problems. But the idea here literally is that you should be able to download code from anyone and run it in a sandboxed environment, and it won't have access to the file system unless you give it to it. It won't have access to the network unless you give it to it. It won't have access to spawn threads and things like that unless you give it to that. So our code will be both portable, but also safe. And we've had environments like that, but we haven't had them also then be fast. And so the idea here is that we will get near native performance with the code portability and the ability to run at near native speeds in a variety of these environments with the kind of security constraints that we really need to protect against some of the attacks that we're seeing. So that's the basic vision. I want to show you a little bit about the outcome. But the other part of this is that we are going to have a binary representation of the code. And it keeps the payload small. It makes it easy to validate. One of the first things that was added after, so WebAssembly was defined under a set of specifications called the MVP back in 2017. And there were some omissions, some fairly large omissions, in that it did not include threading support or exception handling or garbage collection. Not that they couldn't imagine how to do that, but it's that not every language supports those things natively. And so they didn't want to over-specify the platform until people got kind of more comfortable with what it could mean. So there certainly are implementations that support garbage collection and threading and exception handling, but they're trying to implement those in the platform in a meaningful way. So once the MVP was released, one of the first things that was added was the ability to do streaming compilation. And so now, not only do we have this compact representation of arbitrary code written in arbitrary languages, but as it's coming across the network, you're able to compile it and take advantage of multiple CPUs. And so that by the time you're done pulling the bytes across the network, then the code is ready to go. Whereas with JavaScript, that's usually when you start validating the process. So we've got a runtime performance boost here, but we also have a load time performance boost, both in terms of the size of the payloads and the speed with which we can validate and optimize it so that it runs in the native ISA of the platform that you're trying to run it on. So if you're running on an x86, the WebAssembly instructions, which are stack-based, will be translated into the x86 ISA. If you're running on an ARM platform or a RISC-V platform, those sorts of things will be available as well. So there's that representation, but there's also a textual representation. So they can go back and forth between the binary and textual representations. So it'll be easy to generate the code. It'll be easy to validate, to test. One of the things that's currently still a bit of a pain is debugging the code. But generally, because it's just a matter of recompiling it into a different target, you can debug it in whatever native tool that you're using for that purpose. And there aren't that many bugs that crop up in the recompiling part to WebAssembly. So one example of a use case. When Tensorflow Js was released, it added support for a variety of platforms and introduced a couple of APIs. So the orange diamonds here represent the APIs that you would write your code against. And the ops API is sort of a low-level, eager, when you write code, stuff happens perspective, which is a slight difference from how TensorFlow proper works. But then there's a layers API built on top of it that is written to be a developer experience very much like Keras. So your application will write against those APIs, but then the code itself could run inside the browser or in, say, Node.js. And inside the browser, there's a CPU-based implementation, backend. There's also a WebGL-based application. When the Whole Earth environment that I mentioned earlier was originally released, it required Silicon Graphics workstations, but within a couple of years, it was able to run on a PC with a GPU. And scientists at the time said, hey, we want to be able to do that as well. And so they pretended like they were doing 3D graphics by using the shader languages of OpenGL to get access to the GPUs. Well, within a browser, the TensorFlow JS team has a backend implementation that pretends like it's doing 3D graphics because WebGL is fairly ubiquitous in the browser environment. So now the code, machine learning code that could be doing training or inference in the browser could take advantage of the hardware that's available in many modern platforms indirectly through the use of a WebGL backend. Outside of the browser, it could run in Node.js, and it could have hardware acceleration at the instruction set level, using GPUs, talking natively to CUDA or TensorFlow libraries on the back end, and the tensor processing units that Google has. Now, why is that important? It's important because the application itself doesn't change, but notice the performance difference. If you just run against the plain JavaScript on the CPU with no hardware acceleration, something like a face detection activity will take close to 3.3 milliseconds, or seconds, 3,300 milliseconds. The same code, unmodified, running on sort of reasonably mediocre graphics hardware, say like on a Mac Pro or a MacBook or something like that, will take 49 milliseconds. And running on a beefier box in a browser could take 5 milliseconds. Outside of the browser in Node, using just hardware acceleration from the CPU, we can get it down to 87 milliseconds, and talking natively to a beefy GTX 1080 or something, get it down to 3 milliseconds. So the application runs in all these different environments. Based on the backends that are available, they will take advantage of the features that are available, and we could see tremendous performance improvements in the results. Now, not too long after this was done, they released a WebAssembly-Based Back-End. So they took a C++-based neural network library, in essence recompiled it, and then used that as the basis for a non-GPU accelerated backend for TensorFlow JS. And what we see here is that across a wide variety of hardware, that version is able to, for the most part, keep up, or at least be within the ballpark of the performance of the hardware accelerated WebGL-based backend. And so that opens up the same code to now be able to run performantly in a wider variety of platforms, including potentially devices that don't have good hardware acceleration but still have pretty decent CPUs. And so I mention this because even in the space where we had a good story with the WebGL backend, WebAssembly has a place to extend where the code runs with performance. So a reasonably decent CPU would be able to do the inference and the training in the same environment, but the application itself doesn't have to be changed. And so that's the kind of thing that I think you should use as the mental model for using WebGL in the browser as one use case, right? If there's a portion of the code that could be optimized by using something like C++ or Rust, then that's a very trivial thing to do. Now, at the same time, we have the ability to take existing code and recompile it. So Robert Abu Khalil has this great site called JQ Kung Fu, and he has a site with some great resources called Level Up with WebAssembly that you can get to down here. But what he did is he took the JQ command line tool, recompiled it, and it's now available to run within the browser. So as you're doing stuff within the browser using regular JavaScript and HTML, if you need to do something, for example, like strip off all the elements of a collection of JSON, notice you can give it the query. The JQ command line tool basically selects elements from JSON. So dot bracket bracket says pull out all the values from this collection, and then I could say dot email. And so this is like a really quick way of stripping out the email addresses of everybody that was in the original data set. Now, could we have done this in JavaScript? Of course you could have. And you probably, people probably have done stuff like that in JavaScript. But the point is the JQ library exists, it's useful, it already has a query language, and simply being able to recompile it and expose that behavior to the browser is a very cool idea. So that's another use case of something to think about. But if we can do that with command line tools, what's to stop us from doing that with, say, Clang? The Clang compiler has been compiled to WebAssembly so that it can compile arbitrary C++ code in the browser, right? So I'm going to click this little compile button here. This is going to compile it into a 6 kilobyte file, and then I can run that in the browser. And so this is now running C++ code. It's downloading some scripts, I think. In a second, we should see it kick in. Yeah, there we go. And so this is arbitrary code written in C++, compiled by a C++ compiler, compiled to WebAssembly, so that other C++ code could be compiled to WebAssembly. There's a stack of turtles in there somewhere. So that's another use case, right? But once we have the ability to do graphics and recompile existing code, then things like third-party user interface libraries are able to be recompiled as well. And so now the idea of taking existing applications and running them, this is a C++ OpenGL-based user interface toolkit that now runs in the browser with an extremely different application model than, say, JavaScript frameworks would. But now things that historically would have had to have been installed can be simply recompiled and run in this new space. Now, this link won't work for you because it's just a long link that I'm serving up locally. But many of you may have remembered seeing the Epic Zen Garden as sort of Apple's basis for showing off their hardware a couple of years ago. Now, this is based on the Unity engine. The Unity engine has been compiled to run in WebAssembly. So what it's doing now is it's loading this in, and we have this extremely beautiful, elegant, which is probably slightly jittery coming over the network, right? But you get the idea. This runs in Firefox and Mac OS. The same application would run on Chrome and Linux or Edge and Windows. And you start to get the idea of why this is so useful. Is because people, video game companies, application developers, are going to be able to target wider varieties of users without having to necessarily go down the route of lowest common denominator kinds of platforms, or to give up much, or even have to do a whole lot of rework in the process. But we're also doing so within the context of the web environment. And so we can take advantage of what's already there. And this is my favorite example of that. Colin Eberhardt did this Sudoku Solver, where he takes a piece of paper, right, with an unsolved Sudoku game on it, holds it up to the camera, uses WebRTC to get access to the video frames, takes the video frames, uses the OpenCV computer vision library to orient the image, uses TensorFlow to do the detection of the given numbers already in black, takes that representation, sends it into a Rust Sudoku solver, solves it, brings the result back, and then re-renders it in the video frame. That's what's going to be possible in this world when we can take existing code and tie it into our existing web environment. I do a lot of machine learning training, and I often use things like Jupyter Notebooks. Jupyter Notebooks requires us to have this back-end server because Python doesn't run in the browser, right? Well, of course it does, because Python runs on the C engine. The C engine has been compiled to WebAssembly. I now have the ability to run these notebooks directly in the browser. So this takes a second to boot up the Python plugin, but once it's there, it will be ready to go. And you can see we can do regular Python code here, right? Sorting things, creating lists. You can even modify the DOM indirectly from Python, right, to interact with things. So we can run Python. It's part of this larger project called Iodide, which Mozilla is now spinning off as of yesterday to a separate project. But the idea is to be able to have a web experience that involves direct manipulation, user experience, and other things that will make the learning process so much more compelling than we have seen in the past, right? We can imagine, physics textbooks and chemistry textbooks that are interactive, and all of this stuff can run directly in the browser. So some really exciting things coming there. One of the things that will probably catch some developers slightly off guard is the concept of Blazor. Blazor is now Microsoft's .NET environment that allows you to target either running on the server backend or in the browser. So if I take this and I push some buttons and go out and fetch some data, right, this looks very much like a .NET application. And there's a reason for that, because the Zoom thing gets in the way a little bit there. If I look at the developer tools and reload this, you'll see that I'm downloading a bunch of DLLs. And the reason that works is because the Mono platform has been compiled to run in WebAssembly. So you can now take .NET applications, in essence, compile them to be desktop applications, compile them to be run in the back end, or to compile them to run in the browser, and they can be served up. And one of the major hurdles in enterprise software development, which was removing the need to install software, gets eliminated when you can just serve up the code in that way. So finally, just to wrap it all up with some final examples, this is a demo from Google's code conference several years ago. It is an SVG image that has embedded JavaScript that has an animation frame that uses a physics engine written in C++ to position the sand elements in the hourglass figure. Because this also supports animation, I can flip the sand glass and change gravity, and obviously it'll pull the sand elements down. By the way, these sand elements are DOM elements. So a physics engine written in C++ is positioning DOM elements in the browser. Wrap your head around that. Finally, I said 25 years ago, there was no way that we could do what we were doing in the browser. The idea would have been laughable. But now, thanks to WebAssembly, Google Earth runs in the browser. But it also takes advantage of the fact that the browser can go out and fetch content. So you can zero in on a part of the world. It can go out and fetch images and pull in Wikipedia context and all kinds of cool things. So again, this is sort of the best of both worlds, so that we've got the ability to do all of these things. So as you can see, there's already a tremendous amount that we can do directly in the browser. But as Lynn Clark's fantastic overview here showed us 3 years ago, that's just this part of it right here, with maybe a little bit of this, right? This is the MVP that gives us the compilation target, the fast execution, the compact representation, and we emulate memory. So when we have pointer arithmetic and whatnot in C and C++, we're not actually poking around in arbitrary memory. We're using typed array interfaces to a linear memory block in JavaScript. And so we're emulating that. And everything that you just saw is enabled by that capability, as well as a little bit of this. But we want to be able to take heavyweight applications, things like Adobe Creative Suite, Final Cut Pro, Lightroom, and just be able to run them in the browser. So we need the ability to have better thread support, SIMD vectorization, 64-bit memory addresses, tiered compilation, the ability to cache WebAssembly modules, right? All that's coming in there. Better interop with JavaScript, the ability to run Elixir, Erlang, Java, other languages like that in the browser, Scala, that's all coming. Node loves this because we no longer need to worry about native libraries. You have a dependency, you can have a dependency on a WebAssembly version of low-level code to optimize something, but then that will run on any platform, and we don't need to worry about Node jipping the right stuff anymore. But we also have CDNs, edge computing, blockchain, portable tools, Internet of Things devices, right? All of this is being encompassed by the WebAssembly environment. So, as I said, WebAssembly provides the code portability. We still need APIs. Part of the reason why the browser was such a successful first target platform is it's a very rich environment. It's got the ability to do 3D graphics and 2D graphics and sound and things like that. But if I took a simple application in Rust, like a hello world that prints to the console, that's not something that would run necessarily unless you give it access to the console, because there is no standard library in WebAssembly. So in this case, I could take this, recompile it with a different backend. Rust, being an LLVM-based language, simply allows you to add a WebAssembly WASI backend, and this will emit code that assumes the availability of things like file access or console printing and whatnot. And I can compile this down to a small portable representation that, when run within a WASI compliant environment, will give me potentially that ability. So Wasmtime is an open source project that supports the WebAssembly services interface. You can git clone it in its submodules, build it, install it, and now that is going to just be able to run the application directly, in part because Wasmtime gives access to the console directly. Wasmtime does not give access to the file system directly, or the ability to open up network connections or anything like that. So there are other environments like Wasmer and Second State, and there are emerging other WASI or WebAssembly containers that aren't browser-based that are still able to provide a host environment with the sandboxing and the fine-grained access to network and file access. So completely different platform, download it, and it is also able to run the WebAssembly module because it also provides the same WASI APIs that it's expecting. So while we expect WASI to initially be like a POSIX replacement, I fully expect that there will be other WASI implementations that emerge here and there for things like 3D graphics and cryptocurrency contracts and encryption. So you can then say, I need an environment that provides these abilities, like a Win32 API, like a POSIX API, but that will be provided by the WASI environment. Notice we can now run things like Lua in the Wasmer environment or the Wasmtime environment or in the browser, right, with a WASI support there. We could run SQLite, Nginx, right? Redis has been ported to this. Now, these are all early days for stuff that's that complicated, that deals with that much performance and network access and things, those details. But we're getting to the point where those things are not at all that challenging. Now, the Wasmer team has put together a package management system, very much like NPM. So now you can say, hey, I want to wapam install cowsay, and now this code is installed and it runs in this environment, and it doesn't matter what language it's written in. It doesn't matter where it comes from, generally. We have a module system that is also sandboxed, portable, and safe. You can install the core JavaScript engine. So this was originally about running WebAssembly in JavaScript environments in the browser. Now you can run JavaScript environments out of the browser on WebAssembly. So this wapam run basically kicks in the Wasmer environment and allows you to execute JavaScript code there. You can generally run WASI code in Rust, in C++, in Java, in .NET, in a variety of other environments. You can pull in these modules and get reusable code libraries with easy interfaces there as well. I'm not going to go through this. I'll let you go through this demo on your own. But basically, if you go to this, there's a file that you can download. And there's a C++ application and a Rust application, and it copies a file from one location to another. And if you just walk through the demo, you'll see that at first, it won't allow me to when I use the WASI version, because I don't have access to the file system. So I have to give it access to the file system, and then it has the ability to do so. And then Wasmer and Wasmtime both provide the same kind of capability. So we're seeing the emergence of a collection of APIs and environments that implement them. And that's going to include the ability to allow you to write an application against those APIs, just like with Tensorflow Js, you write against those APIs, but it will run in a variety of environments, including as a hosted application in a WebAssembly environment, native OS, bare metal server, not virtualized, through a web polyfill, etc. So our code will get portability from WebAssembly, and our applications will get portability from WASI. And the final thing that I want to do before I hand it over to the questions is to show you that we have the ability to run shell environments as well. So if I clicked on this, I could be taken directly to a shell environment. And I could say, wapam install cowsay, right? And it would go out and install cowsay, and then I could say, hello, craft. And so I'm now running this arbitrary application written in arbitrary languages in a browser, right? No code had to change. So we're going to get the ability to do like what we were doing with TensorFlow JS. The application runs in these different environments, takes advantage of the hardware that's there. WebAssembly has extensions for threading and SIMD vectorization and 64-bit memory environments and things like that. But the world is changing very quickly. And notice I could send you a link to say, open up this environment with SQLite installed, and you could run SQLite in the browser as well. So I'll let you play around with those. But I also encourage you to check out things like the Bytecode Alliance, because we're seeing industry support for portable, secure, fast environments. And ARM and DeFi and Fastly and Google and Intel and Microsoft and Mozilla are excited about having these sorts of environments. And just to put a fine point on it, when Solomon Hykes read about this not too long ago, or a couple years ago, he said, if WebAssembly and WASI existed before we wrote Docker, there would be no Docker. So that gives you a sense of what is possible with a combination of these technologies. So I hope you're interested. I hope this is interesting. I am working on the book. It is not going as fast as anybody wants, but it's making good progress. And if you're interested, you can access the early, I think there's like 10 chapters up now in O'Reilly's Safari online early access. I'll be having another several chapters up in the next couple of weeks or so. So I hope you get in and see how a lot of this works mechanically. So thank you very much for your time, and I'm happy to answer any questions if there are any.
Wow, that was amazing. Thank you. Yeah, my mind is still kind of like, what TensorFlow and OpenCV and what did you put into my browser? And okay, so yeah, we do not yet have questions. So I'm just gonna just take this time to say, you got questions about this. This raises a lot of questions for me. Put them into the Q&A section. Just letting you know, there is some kind of latency between how we're talking here and by the time it gets to the stream, so it's gonna take a bit of time for questions to really start showing up. It's gonna take some time for people, I think, to digest this.
Sure.
Yeah, someone was joking how you should use this to bring back Silverlight, and then like half a minute later, oh wait, someone already did that.
Somebody already did it. Yes. So definitely, and that's kind of the thing that we're trying to go for is, again, the ability to write an application that could run in any of these environments. We're going to need a user interface platform, and currently there isn't an official one, right? And there doesn't really need to be, but if you poke around, you'll see that you can even run like Windows 2000 in a browser, or DOS or Linux in a browser, because of this.
Yeah, that's amazing stuff. And just without even thinking about what this is useful for, just as an engineer, this makes me so happy.
Yeah, no, and again, this is one of the things that I really like to highlight is the design teams took a very surgical approach to this, right? They didn't just say, let's re-implement everything in WebAssembly. The goal was to allow you to be able to get reuse out of existing libraries. And that's useful from a business value perspective, but it's also useful from a code provenance perspective, right? If we have encryption libraries or things that we want to come from trusted partners, we don't necessarily want then somebody who doesn't really understand encryption to rewrite it in JavaScript and introduce a lot of timing attacks, right? And so the idea of just being able to take code from trusted sources and recompile it and run it in the browser. And again, keep in mind, this is not actual C code running with pointers into your heap. The pointer arithmetic is emulated, but it's emulated very elegantly on the back of JavaScript environments within the browser and in other sandbox ways in other places.
Yeah, it's magical. Okay. It makes me wonder, like, if your wildest dreams come true in, I don't know, like 5 years, like what's this gonna mean? Like, is everything just gonna be on WebAssembly? Or what's the?
So I have said quite provocatively for a couple of years that I think WebAssembly is going to kill, sort of native desktop development, as a separate thing, just because it's not going to need to be. Like, there will be new libraries. Like, people will write .NET applications, but I think once people get their head wrapped around it, there will be new fancy portable user interface libraries, that are designed to work in this environment. And then people will start writing applications against those. I think the APIs will be available through both WASI and non-WASI implementations. We're seeing some people already using WebAssembly as a targeted backend. The Uno platform allows you to target .NET in the browser, on Windows, on Linux, on iOS, all these different platforms. They're thinking sort of three-dimensionally about this. And once more people think three-dimensionally about this, then ultimately I think the real value is you're going to be able to write code and push part of it down to the device, your phone or tablet, part of it into the edge computing environment or the cloud computing environment, part of it into a desktop backend, part of it in the data center. And it's going to be portable and safe and fast in any of those environments. And that way we really can start to optimize, like, when do we need hardware acceleration and when don't we? And when is latency an issue and when isn't it? And so portions of our applications will want to be run on the edge, portions will want to be run in the cloud. And it's never going to have been more important to think about things like location and where do we put our compute and where do we put our data, and how does hardware impact these things. But it's nice by having these layers that allow us to mediate over a lot of those differences. I think that's going to be useful. So I do think it's going to have a huge impact on how we build software. I think things like the JVM are not going to be all that interesting for long, because that's just another target platform. Now, WebAssembly does need to add support for garbage collection and threading, but there are working versions, and there's a team who have a compiler called Chirp-J that allows you to compile very sophisticated software to run in the browser. So even like Swing applications can run in the browser using that approach. So, I think it will impact things like container environments and desktop environments and things like that. But I also think there's interest in moving into more and more custom hardware. IT sovereignty is becoming a huge thing. Like there's the European Processor Initiative. India is starting to get into chip manufacturing. RISC-V is opening up who this is available to and the kinds of like custom extensible hardware that people are going to be creating for like co-processors of certain kinds of calculations. And again, having code that will run in any of these environments, and including with the Bytecode Alliance, has this notion of an embedded environment. That was just a nut Java was never able to crack. So you can have your code run in embedded, safe, fast, portable environments on devices with like Nano Jetsons and Azure Spheres and things like that as well. So
yeah. Awesome. Yeah, that sounds very exciting. I am sad to report that I made the classic MC mistake of asking a question to fill time, and then real questions started coming in.
Okay.
We have roughly 5 minutes left, so we'll get to some of those questions. Where can people reach out to you to discuss the rest of this excitingness?
I'm on Twitter, so Sletten is my Twitter handle. That's an easy way to get in touch with me. My email address is my name, separated by a period, at Gmail. So you can send me email, and I'll try to respond there as well.
Awesome.
There's a lot of great resources that are out there, and I'm happy to share many of them.
That's great. Yeah, actually, one of the questions is, if someone's not familiar with WebAssembly yet, where would you recommend starting?
It's a tricky question, and it's hard to write a book because I can't assume. When I proposed the book, I said the audience was really going to be like JavaScript developers who've never used a compiler, C++ developers who are suddenly happy that they're relevant on the web again, and then sort of like newer developers in languages like Rust and Go, interested in the architectural implications. So it's a hard question. It really depends on what your interests are or what your background is. Whether I would say start with something that's language specific. There are some really great Rust and WebAssembly tutorials, and Kevin Hoffman's book from the Prague Progs is a fantastic introduction to that pairing. But there are other like WebAssembly in action for C++ based approaches. Robert, as I said, Abu Khalil's Leveling Up with WebAssembly is a great resource that's available there as well. So get in touch and tell me what you're interested in, and that will help me tell you where to take a look.
Nice. That's amazing. Thank you. Let's see. One of the top rated questions is, does WebAssembly offer solutions for file system access, or will data have to remain temporary in network due to the sandbox nature?
Excellent question. One of the things that WASI will provide is a file system abstraction. Now, it may basically go directly to a standard library implementation if you're running as a native OS application outside of the environment. But within a hosted environment, you may be given access to a constrained version that only allows you to look in certain directories, right? Within a browser, you can have a file system abstraction over local storage. So again, your application doesn't really have to know or care, but it can write as if it's writing to a file system. And in fact, in my book, I did that with a Windows bitmap generator of fractals. It is a standard tool that wrote the files out to the file system. But when I run it in the browser, it runs and writes it to local storage. And then I can load it out of there from within JavaScript. But you can also imagine an implementation of the WASI file system API that writes out to your S3 bucket. So the point is you're going to get data location portability as well. And that's not something that the application is going to have to care a whole lot about.
Yeah. Cool stuff. I think last question here is going to be one that it's kind of a fun one, but I feel like there is a potentially some real worry in there. What does this mean for JavaScript / web developers?
Yeah, so it's a common question. Like I said, people think this means it's the end of JavaScript. It's not. Brendan Eich is a huge fan of WebAssembly and was a big part of its formation. A lot of the JavaScript frameworks have already rewritten portions of themselves in languages like Rust or C++, but they're still exposed through JavaScript in ways that you wouldn't even notice, except they get faster. So on its own, I would say there's no real concern that WebAssembly is going to disrupt JavaScript. I do think things like Blazor are going to change like what enterprises are willing to pay for. Right? Enterprises have allowed developers to do JavaScript framework development for a while, but I think we chased a lot of shiny objects and haven't produced a whole lot of value. And once enterprise business stakeholders realize that they can pay C# developers and recompile to run in the browser, I think that's going to impact within that environment what kind of JavaScript development there will be. But startups and researchers and people will still be doing lots of JavaScript framework work, and like I said, those frameworks themselves are taking advantage of WebAssembly where it makes sense to. So definitely keep your eye on the ball, because these are disruptive and changing technologies, but I don't think that it's going to kill JavaScript in any way, because a lot of the time, for certain kinds of things, JavaScript is as fast or faster. But it's when you start needing the code portability and the safety and the sandboxing that, being able to run JavaScript in a WebAssembly environment would also be of interest. And we can do that now in many cases as well. So,
yep. Awesome. Good stuff. Thank you again for the talk and for answering all these questions.